Hello, my name is Matthew Randall, and in this series of tutorials, I want to show you how we can combine camera projection and camera tracking and camera projection inside of Nuke to do plate cleanup and rig removal. So in this case, what I'm going to do is I want to remove these grate markers from the floor here, but equally I could use this to remove tracking markers and other objects that I want to get rid of and clean up in my scene. So if we just look at this scene in more detail, so we can see that the camera kind of moves around a bit. It sort of shifts around a bit. So we've got a couple of problems that we're trying to deal with here. The perspective shifts around a lot, so we can't really just use a tracking node. And also the pattern on this carpet and the focus shifts a lot. When I say the focus shifts a lot, it's not the focus, it's just the motion blur. So there's a lot of motion blur on this, on certain frames, and the pattern on the carpet's quite dense. So that makes the planar tracker quite, it means the planar tracker doesn't work as well as it could. And kind of slips a lot and makes it difficult to use. So if we look at my completed version here, this is my completed version where I've removed that element. Okay, here we go. So I've removed that element there. Okay. Basically the way that I've approached this is I've performed and I do apologize for sort of how messy this is. I'll try and clean this up a little bit better. But I've basically performed a camera track to reproduce the movement of the camera that shot this scene. I've then created a card, which I will just show you now. Here we go. Just going to connect that up. Here we go. I've created a card which exactly reproduces where the floor is in our scene. Okay. Once I've done that, so once I've reproduced the movement of the camera and the geometry of the bit that we want to clean up, what I can then do is I can then pick a frame. I can make a copy of the camera at that frame, and then also render out the original footage on that frame. I can then just clean up that one still, and then by reprojecting that one still from the camera that we've copied here back onto this geometry, what we end up with is a little patch, which I will show you here. Here we go. A little patch here, okay, which we then project onto this card, okay, and then that covers up. So as the camera moves, that actually covers up the grate for us. And I've only done the one grate here, but we could use the same technique to cover up multiple grates. And that covers up that one grate. That covers up that grate for us. So as the camera moves, because we're using projection, it means that to project it onto this geometry, what it means is as the camera moves, it will see that geometry from the correct perspective, and everything will look fine. So what do we want to do? We basically want to do a camera track. We then want to create so we want to do a camera track. We then want to create a geometry to match the geometry that we're projecting onto. And then what we want to do is do our projection. Okay. And then there was a couple of other issues as well in terms of matching up the blur, which we will talk about and clean up later on. Okay. So let's get started. So first of all, what we want to do is do a camera track. So in Nuke, we have something called the camera tracking node. So I'm just going to open that up. So I'm going to camera tracker. Okay. I'm just going to put that through a camera tracking node. And actually what I did with this plate, just to kind of help things a little bit, is I put this through a color corrector node. So I'm just going to go color correct node. Okay. And all I did with this node was just to up the contrast. If I just put that through the viewer now, is I just up the contrast a little bit in order to I just up the contrast a little bit. In fact, did I use this one? Yes, I did. In fact, sorry, I used color lookup, so I'm just going to delete that. So look, color lookup. there are different ways of doing this, but essentially what I want to do was just up the contrast a little bit, just to make life a bit easier for our camera tracker and hopefully improve the results that we got. Okay, so here's our master, and you don't want to overdrive this, but what we can then do is obviously push down the darks, push up the blacks. Okay, so all I'm doing is just selecting the master here, but there's different ways of doing this in Nuke. Okay, but all I'm trying to do is just really push up the contrast a bit, just so that we've got a bit more to track here, and you can see that it's pulling out the details in this floor a little bit more as well. Okay, so that just helps our tracker a little bit. Let's go back to the tracker that we've got on here. So I'm just going to double click on that to push that to the top of the properties menu. Okay, so now what I want to do is I want to do a camera track, but we need to specify some information about this camera. Okay, so what we want to do is it's a free camera movement, so that's fine. Okay, if we were doing a pan or something, you might want to select just like rotation only. Okay, but it's a free camera movement. Lens distortion, well, it's got a lens on it, so it will have some lens distortion on there, but we don't know what that is. We haven't done any lens distortion charts in this case, so I'm going to say unknown lens. And then the focal length, so this is the focal length of the lens that we used. We do know what it was, and it was 24 millimeters. So I'm going to put that in, okay? And it was a fixed focal length, okay? And then what we can also do is specify the film back. So it's actually a Blackmagic camera, and normally you'd have to go and look this up. But one of the things that's quite nice about the camera tracker node in Nuke is that it does actually have some presets in there, depending on what camera you've got. Tends to be more sort of, well, I'm going to say high end, but they're not all high end. So if I go to the Blackmagic and select the Blackmagic Cinema 2K camera, that's the one that I shot it on, it'll automatically pull in the camera back size for us. So the camera back size is the size of the camera sensor. So if you've got a camera that's not in that list, which is could easily happen, then what you want to do is look up the size of the sensor and put that into here in millimeters. Okay, so with that done, what I'm going to do is I was going to do a track, but before I do that, actually, it's going to refine a few things. So I was going to go to my, look here. Yeah, go into my settings. I just want to up the number of features that are doing it. If I go preview, it's not tracking that many features. I want to track more features. So I'm going to go like 400, I think. Sounds like a good sort of number there. And I'm just going to push up the detection threshold. What I want to do is I don't want it kind of detecting things where there isn't that much contrast. So I want it to look for contrast. Where there isn't much contrast, I want it to kind of ignore that. Okay. And the other thing I like to do is specify the minimum number of frames that something has to be tracked for. So I like to kind of go for 10 and say you can only, if it must track for at least 10 frames. Okay. Right. So with that done, I am going to go track. And you'll see it'll take a little while, but it's going to go through and it's going to go and track our scene. I will pause while it does that. Okay, so this is the result of our camera track that we have here. What I should also just make clear as well is that within this scene, there are people in the scene moving around. And I suppose if I was doing this properly, I should really mask these out just using a roto and just keyframing the positions of the roto just to cover these little patches. And then I could feed that in as a mask into the camera tracker. I'm just trying to see if I can kind of get away without that. Okay, so yeah, so I've done a 2D track and I've done my track. And what I'm going to do now is click solve in order to take. So what's happened now is it's tracked all these points in 2D space. On the screen here, okay, but what I want to do is actually use those. What I want to do is use those points to work out where the camera is and all these points that it's tracking are in 3D space, okay. And to do that, I click solve. And what's happening is the computer's using the way that these points move in relation to each other in 2D space to work out where the camera must have been in 3D space, okay. So I'm just going to do a solve. And I will pause while it solves. Okay, so now we have a solve, okay, and it's still giving us an error here, okay, so letting us know how well that went, okay, and we really want to get this down really kind of like towards 1, ideally below 1, okay? But this is just an error value. It should only be used as a guideline. Often I'll get something with a low error value, and it's not tracking correctly. So it doesn't mean it's tracking correctly if it's a low error value. You do need to inspect and look at the track in order to make sure that that's working correctly. So what we want to do is let's just go into our auto tracks. And one of the main things I want to look for is, let's have a look at the minimum length. I think we've kind of taken care of that anyway. Let's have a look. So if I just select these two, I'm just going to press Control to select these two, press F. Hang on, sorry. Track minimum. So I want track minimum and I want min length. Let's have a look. I will get these two selected correctly in a moment. Here we go. So that gives us an idea of what we've got. I think we've got the minimum at 10 anyway. So that's not really... I think that's fine anyway. So I don't think we're going to worry about that. What I'm more interested in then is clicking on the max error and then clicking on the error max and the max error. So what this is looking at is we have something called error RMS, and what that's looking at is are there any track errors? So basically it's looking at how confident it was about the 2D track, that it performs, how well it was able to track a particular point in 2D. Okay, and then this one, the error max here, is looking at how confident the system was in terms of how well that track corresponded with the 3D solve. So it's doing a 3D solve, and there's going to be certain tracking markers which that 3D solve, and it's trying to do the 3D solve to fit all the markers that we've tracked in our scene. But clearly there's going to be some that are slightly off. So it's going to, so any markers where the position doesn't really match the solve that well, that's what it's going to be showing up in here. So it's showing up how well it thinks that marker matched the solve. Okay. So what we want to do is we want to grab our max error. So I'm going to click on max error here. This is our threshold. Okay. And if I move this bar, anything below this is sort of saying, well, it doesn't really fit the 3D mark, and we're not that confident in it. So I'm just going to chop that down and chop quite a few of our markers off there, okay? And then what I'm going to do is, I'm just going to go and do that. And I'm going to go delete rejected. So any that are rejected, we're going to delete, okay? And any that are unsolved, we're also going to delete, okay? And now what I'm going to do is going to back here, and I'm going to go and do another solve and see how that works. So again, I will pause. Great. So essentially what we're trying to do is sort of go, we're trying to just remove any tracking markers that we're not particularly happy with. Okay. What I might also do is just have a look at the RMS on this one. RMS, and I think it was the max error track, or in fact, sorry, error track, max error track, and go F. Okay. Error min. And max track error. I'm going to look at the error RMS and the max track error. Okay, let's just focus on these two. And what I can do is also just bring this down. So this is looking at refining the 2D points that it wasn't so happy with. Let's have a look what we've got here. So it's removing a few. I reckon I'm going to bring that down there. So let's go delete rejected. Yes. Okay. And let's see how that improves our solve. That has improved it dramatically. So let's do another solve and see what results we get. Okay, so we've done another solve. I feel that that's a much better error rate, so I'm feeling a bit more confident about this track now. Now, hopefully, if we go into our 3D version, so if I click on 3D, what you'll see is it's created a point cloud here. And this is where it thinks that each of the points that are in our 3D space are. Okay. In fact, what I'll do is, before I do that, actually, what I'm going to do is, if I go back onto my settings, yeah, that's all good. Okay. So one of the things I'm going to do is, once we've done our camera track, what we can do is we can tell this camera tracking node actually just create a set of other nodes for us based on that camera tracking data. So if I just go into Scene Plus, that's typically what you do, and go create, it's created a whole load of other nodes for us. So it's created a camera node, and this camera node is the actual 3D representation of the camera that shot this scene and its movements. It's created a point cloud, which is basically a 3D point to match every single position of, so to match the position of every single tracking marker. It's created a lens distortion as well. So what it's doing as well is it's working out what kind of distortion there is on our lens as well. So it's creating some lens distortion there. This is quite useful because what we can do is then later use this node to reapply lens distortion to any 3D elements that we might be rendering and putting onto our scene. Okay, or removing any lens distortion that we want. So at the moment, this will be set up to remove lens distortion. Okay, so that what we get into our background image here is basically a straight undistorted image. Okay, but we could take a copy of this and use it to remove the same lens distortion if we wanted to. Then the scene is just a 3D scene, so that the tracking points of the camera are in this 3D scene, and then this scanline renderer is what's used to render out that scene. So if I click on here, effectively what we see is the point clouds rendered on top of the video that is going into via the lens distortion node, the same scanline render, but going in as a background here. Okay, so let's have a look at this in 3D. Okay, and what you'll see is if I play this, we've got our movement of our camera sort of moving forward. That's our free moving handheld camera. Okay, and then we have all the points here that are our points for our track, and this looks relatively okay. This is representing the floor, okay, and you can see the slight little peaks there where we've got tables, chairs, etc., in that space. So one of the first things I want to do, if I'm going to match some geometry to this, is I want it so that the point clouds are actually so the point clouds aren't going up at this angle here, i.e. the floor of our scene isn't going up an angle here. I want it to the floor to make it easier for me to create the geometry to match the floor. I want the floor to go along the floor of our 3D scene. Okay, and what you have to understand is all the computer understands at the moment is the relationship between the camera and the 3D points in our video that we shot. Okay, it doesn't understand the orientation of that camera or the 3D points. It doesn't understand how those are orientated or located at the moment. So we need to give it a little bit more information. So what I'm going to do is I'm going to select the camera tracking node, and what I'm going to do is select a load of these points. So I'm just going to go and select, just going to press Shift and select a load of points that are on the floor here. Okay. Something like this. And some over here. Okay. So I'm going to select a load of these points, and then what I'm going to do is tell the system that these points represent the ground. Okay, so I'm going to right click and I'm going to just go ground plane, set to selected. Okay, now if I go into my 3D scene again, what you should see is that the whole scene, so I'm just going to render it, push this out from the camera's point of view. So I'm just going to put the camera into our viewer here, our 3D viewer. So obviously if I put it into the 3D viewer after the camera's gone into it, I will see the camera as well as the point cloud, and I want to see that relationship. Okay, so you'll see that it's moved all these points and the camera, the whole thing, so that it's orientated towards the so those points that we selected are now on the ground. Okay, so what I want to do is I want to create a geometry that matches our ground plane. Okay, and I want to see how well that geometry matches up. So I'm going to create a card. Okay, so it's just going to be a flat plane. Okay, and I want to add that card to our scene. So I'm just going to add that to our scene. Okay, let's put the viewer down here. It's going to move the lens distortion node over to here, and I might just move this dot as well, just to kind of clean things up. So here's our card. I need to put something on that card so that we can actually see it. So if I just go, I think if I go checkerboard, I can create a checkerboard pattern. And I'm just going to put that checkerboard pattern onto the card. Okay. So now if we look at this in 2D, we can actually see, yes, we've got that checkerboard being overlaid on the top of it. Also, I don't want these point cloud bits at the moment, so I'd like to remove those. Rather than deleting the node, because those point cloud information can be quite useful, I'm just going to go press D, okay, just to disable that node so we don't see that. We can see that our checkerboard is actually not at the correct angle that we want. So if I go back into my 3D, let's have a look what we're looking at here. I can see from our 3D that we need to rotate it. So I'm just looking at our perspective here. We want to rotate it along the x-axis by 90 degrees. So what I'm going to do is grab this card here and just translate that card 90 degrees on, sorry, not translate because that's moving. I want to rotate it 90 degrees on the x-axis. So that should now be flat on our ground. Let's have a look at this through our 2D. So we can see that that's flat on our ground. We can't really get a sense of how this floor matches up with the video because how this checkerboard is matching up with the floor in our video because we because I can't see the video through it. So really what we want to do is actually use a merge node. So I'm just going to create a merge node and it's A over B. So this checkerboard and 3D system is our A, okay? And then what's coming out of this lens distortion node is effectively our B, our background. So I'm just going to grab it by connecting it to the dot here, okay? And then I can have a look at that and that should be an A over B. Now what I can do with this merge node is I can kind of select another operation. So I can select something like soft light, okay, and sort of adjust the mix of that just to get an idea of how those sort of fit together. And what I might do is just to help us out a little bit, if I can just translate the checkerboard so that it crosses over where these two are. So I'm going to just try and do a translate here. So if I grab this card, I don't want to translate the checkerboard because that's the image. I want to translate the card that image is being applied to. Okay, let's just move that. See how well that works. Yes. So I'm just going to move that now. Let's have a look. Yeah. So that's going across those points there. Let's now play that back and see how well that track's doing. Okay. So I'm just going to let it cache in, and I shall pause while it's doing. So this is the result that we've got. And I'm pretty happy with that. That's yeah. And all we're doing is just, what we're doing really is just looking to see that if there's any kind of slippage between the checker pattern and the floor. Now, if there's any slippage between the checker pattern and the floor, what we'd probably be looking to do is just adjust either the height of that checker pattern, because that might be one reason why it's slipping. It might be a little bit higher than the floor, but I'm happy with that. With what we've got there. I think that's a solid track. Okay, so that's what I'm going to go with. Okay, so let's pause there and we will continue with the projection in the next video.